Welcome back to General Chemistry mini lecture series, lecture 9, Chemical Bonds and Ions. You may wonder, how do atoms or ions stay together in molecules or in compounds? The short answer is through chemical bonds. So chemical bonds are the forces that hold atoms or ions together. We have mainly two types of chemical bonds. One is a covalent bonds, and that can be found in covalent compounds or molecules. Those bonds are formed by sharing valence electrons between two non-metal atoms. For example, here we have chlorine monofluoride. Both are 7A elements, which means they have 7 valence electrons. So therefore, 7 plus 7, that's a total of 14 electrons. And then we can draw the Lewis electron dot formula right here. That's a total of 14 electrons. But if you concentrate on each of the atom, then there are 8 electrons surrounding each of them. 8 surrounding chlorine, also 8 electrons surrounding fluorine. So we call those octet rules. Whenever the atoms, they have 8 electrons, atoms or ions surrounding them, that's actually more stable. Because of the sharing of this pair of electrons, you see, this is the only pair of electrons are shared. Like this one, this one, this one, those are called lone pairs. They are not contributed to this CLF bond. So it's only these two. These 3 pairs of electrons of fluorine, lone pairs. So we have 6 lone pairs do not contribute to this covalent bond, only this pair. So the mechanism is sharing valence electrons. The other type of chemical bonds are ionic bonds, and they exist in ionic compounds, and they are formed by transferring valence electrons from metal atoms to non-metal atoms. So electrons are not shared like in the covalent compounds. So electrons are transferred. For example, sodium reacting with chlorine. Sodium lost 1 electron because sodium has 1 valence electron. It is very easy for sodium to lose 1 electron and form this more actually stable sodium ion, +1 ion. Chloride, on the other side, it has 7 valence electrons. It loves to gain or obtain 1 more electron, total of 8 now, to be more stable. Noble gases don't form any chemical bonds because they already meet the octet rule. They are very inert. They are very happy by themselves. Octet rule states in compound formation, atoms lose, gain, or share electrons so that they have 8 electrons in their outermost shell. That's the octet rule. So once they are in the octet state, they are happier, more stable. Now let's talk about ions. Ions are atoms or group of atoms with positive or negative charge, which means atoms or group of atoms with charges, then those are ions. Removing an electron from an atom gives a cation. The cation has a positive charge. The opposite, adding an electron to an atom, gives an anion, or negatively charged ions. How do you tell the difference between atom and ions? Just simply look at whether there is a charge in superscript. Examples like here, Na is a chemical symbol for sodium, and now it has a positive charge, means this is sodium ion. It lost 1 electron, and so are the other ions. Here are the atoms. you see corresponding atoms. Sodium losing 1 electron becomes sodium ion. Calcium losing 2 electrons, that's 2 plus. Lose 1 electron, it gained 1 positive charge. Losing 2, that's 2 positive. Iodine, it has 7 valence electrons, can easily obtain or happily get 1 more valence electron, becomes iodide ion. Since it's gaining electron or adding electron, the charge should be negative. So it's the case with oxygen atom and oxide ion. Those are the difference between atoms and ions. Cation ions are smaller than their respective atoms. Lithium, for example, the atomic number for lithium is 3, so therefore it has 3 protons and also 3 electrons. So therefore neutral lithium atom carries a net charge of 0. However, lithium atom losing 1 electron, then lithium plus 1 ion is formed. Now it has still 3 protons but only 2 electrons. You see, the entire outermost shell is gone. You see, this one is gone. Now the second outermost shell becomes outermost shell here in the ion. So that's why the ions are smaller than their respective atoms. That's the reason. Anions do the opposite. Anions are larger than their respective atoms. Take fluorine again as an example. Its atomic number is 9, which means 9 protons. Then therefore there should be also 9 electrons. When that gain 1 electron, look at the outermost or valence shell, it has a total of 7 valence electrons because fluorine is a group 7A element. Gain 1 more, then the outermost will have actually 8 electrons. So that meet the octet rule. This is a happier state. So therefore actually fluoride is very stable. It has 9 protons. The number of protons or atomic number never changes, but the number of electrons are changed. It has 1 more. Then why is the anion larger than its respective atom? Because the electrons, in this case in fluoride, outnumber the protons. We have 10 electrons, 9 protons. So the protons cannot pull the extra electrons as tightly, like here, toward the nucleus. This results in increased ionic radius. So that's why cation ions are larger than their corresponding atoms. Group 1A elements always form +1 cation ion. And they can only form +1 cation ion. Not +2, not +3, not -1. It's always +1. For the transition metals, they have variable charges. But silver always also just forms +1. So therefore, +1 charges, ions, you have group 1A plus silver ion. That's always +1 ion. Group 2A and zinc always form 2 plus ions. Group 3A, aluminum, always form 3 plus ion, and plus scandium. Scandium always forms 3 plus. So therefore, aluminum, scandium, both always form 3 plus cation ions. And then for group 5A, nitrogen and phosphorus, they tend to form 3 minus ions because they are in group 5A, gaining 3 more, then they will meet the octet rule for their outermost valence shell. So make them stable. Group 6A, that's 2 minus. They tend to form 2 minus ions. So these 4. Then group 7A, every one of them, they always just form 1 minus ions. Okay. Group 8A, of course, they are not involved in any of the chemical reactions, so they already meet the octet rule, so they don't form ions. Okay, for those transition metals, they have variable charges, okay, except scandium, zinc, and silver. So you can find, they can have charge of +1, +2, +3, and so on and so forth. Most of you probably already know iron can have 2 positive charge, can also have 3 positive charges. Okay, now let's take a look at the polyatomic ions. Obviously, poly means more than 1 atom in polyatomic ions. Those are the names, and those are the formula. Here, the same. So those are the common polyatomic ions. There is only one polyatomic cation, and the rest of them are polyatomic anions. Pay attention to some of these. Let's see here. Carbonate, this is CO3, and now add 1 hydrogen to it. It's called hydrogen carbonate. This hydrogen actually is a proton, hydrogen ion, +1. That's why the overall is -1 charge instead of -2 in carbonate. Nitrate is NO3, -1. Nitrite is 1 oxygen atom less, NO2, -1. The charges don't change. And then you will have similar, this kind of patterns for sulfate. You see that? SO4, 2 minus, sulfide, SO3, 2 minus. You see, the charge doesn't change, but the number of oxygen atoms are different. If we look at phosphate, it's PO4, 3 minus, add 1 hydrogen ion to it, that is hydrogen phosphate. And then the charge becomes 2 minus. Adding 2 protons to it, we call that dihydrogen phosphate. And then the charge becomes -1. Because here is -3 plus 2, -1. So those are the common polyatomic ions. Quiz number 1. Which of the following is nitrate? So you really have to know the formula and the name in order to answer this question correctly. I just talked about nitrate and nitrite. So this one is actually nitrate, this one is nitrite. If we go back to the previous slide, you see nitrate, nitrite, ATE, ITE. ITE is the one with 1 less oxygen atom. So therefore nitrate is NO3. It's not NO2. NO2, that's nitrite, ITE. What is this one? It's simply nitrogen, or you may say nitrogen molecule. That's a diatomic molecule. What is this one? This is just oxide. It has nothing to do with nitrogen. So therefore D is the correct answer. Of course, there are quite a few more questions you can practice and work on. This is lecture 9. I will see you guys in lecture 10.